Good morning. In last class, we have discussed frequency modulated microwave radio system, which consists of FM microwave radio transmitter and FM microwave radio receiver. We have also discussed about the microwave radio repeaters. Today, we'll discuss about diversity and protection switching. Going on to the diversity system uses line of sight transmission. Therefore, a direct signal path must exist between the transmit and receive antennas. What is meant by line of sight transmission? Yesterday's class also we have mentioned about line of sight transmission. We'll discuss in brief in further classes, but line of sight is a type of propagation that can transmit and receive data only when the transmitter and receiver station are in view of each other without any sort of any obstacles between them. That is, when the transmitting antenna and receiving antenna station are in view of each other, when they can directly view each other, line of sight propagation happens. Consequently, if the signal path undergo a severe degradation, a severe service interruption will occur. If there are some obstacles between the transmission and reception path, a severe interruption will occur in the transmission. Over time, radio path loss varies with atmospheric condition, and that can vary significantly, causing a corresponding reduction in the received signal strength. And the strength may be of 20, 30 or 40 or more dBs. This reduction in signal strength is temporary and referred to as radio fade. Here we can understand what is radio fade. Radio fade is the path loss that varies with atmospheric condition. And that can significantly cause a corresponding reduction in the received signal strength. And it may be the reduction may be of 20 dB, 30 dB or 40 dB or more. This reduction in signal strength is temporary and it is referred to as radio fade. And a radio fade can last for a few milliseconds, which can be called as short term, or it can last for several hours, or this may be called as long term. So, microwave system use line of sight transmission, where line of sight transmission is a type of propagation that transmit and receive data only when the transmitter and receiver station are in view of each other. When the transmitting and receiving station are in view of each other, line of sight propagation happens. Usually the FM radio microwave and satellite transmission are the examples of line of sight communication. So here we are discussing about frequency modulated radio microwave system. This uses line of sight communication. Rather than this communication, satellite transmission or satellite communication also prefer or use line of sight communication. In that, this means that the transmitter and receiving station must be in view of each other without any between them. If some obstacles are between them, a service interruption will occur. So there should not be any obstacles between the transmitter and receiver path, and it should be in line of sight. So microwave system uses line of sight transmission where there exists a signal path between the transmitting and receiving antenna. There should be a straight line path between transmitting and receiving antenna. And if there is any obstacles between transmitting and receiving antenna, a service interruption will occur. And now we will discuss about the radio fade. Over time, radio path losses vary with atmospheric condition like moisture, humidity, etc. That can vary significantly. As the time increases, as the time goes on, atmospheric condition can vary significantly. This creates the radio path losses, and which result in reduction of received signal. As a result of variation in the atmospheric condition, radio path losses occur, and as a result of radio path losses, there will be reduction in the received signal strength, which may be of 20 dB or 30 dB or 40 dB or more. The reduction in the signal strength is temporary. It's not permanent reduction, and this is because of the atmospheric condition that may not be a permanent condition. And as a result, the reduction in the signal strength is temporary, and this is referred to as radio fade. And this radio fade, which is not temporary, temporary, can last for few milliseconds. It may be it may be few milliseconds, or it can last for several hours or even days. And if it is lasts for few milliseconds, it is short term. And if it lasts for several hours or even days, it is termed as long term. Now, the automatic gain control circuit built into radio receiver can compensate for fades of 25 dB to 40 dB depending on the system design. However, fades in excess of 40 dB can cause a total loss of received signal. When this happens, what is automatic gain control circuit? AGC is basically a closed loop feedback regulating circuit in amplifier or chain of amplifier. The purpose of this AGC or automatic gain control circuit is to maintain a suitable signal amplitude at its output. This AGC or automatic gain control circuit maintains the signal amplitude at its output despite of the variation of amplitude at the input. Independent of the variation of amplitude at signal at the input, this AGC what it does is it maintains a suitable signal amplitude at its output. So AGC circuit is built into radio receiver and can compensate for fades of 25 dB or fades about 25 dB to 40 dB depending upon the system design. This AGC is built in radio receiver. This compensates the radio fade up to 40 dB. In the range of 25 dB to 40 dB, this AGC can compensate the radio fade depending upon the system design. However, the fades that is excess of 40 dB can cause a total loss of received signal. When this happens, service continuity is lost. AGC can control only the radio fades about 25 dB to 40 dB, and when the radio fade is more than 40 dB, there is a total loss of received signal. And when this total loss occurs, there is a service continuity. The service continuity is lost. So, diversity suggests that there is more than one transmission path or method of transmission available between a transmitter and receiver. So, before going that, simply we can define the reliability of message signal. That is, the consistency, reliability of a message signal means the consistency in performance of a message signal by using two or more communication channel that have different character. So diversity suggests that there is a more than there will be more than one transmission path between a transmitter and receiver, for method of transmission available between a transmitter and receiver. Diversity, once again, diversity simply means a method for improving the reliability. Reliability in the sense that the consistency or the performance of the signal, message signal, it just maintain or improve the reliability of the message signal by using two or more communication channel or two or more or more than one transmission path or communication channel, or which this transmission channel or the transmission path or the communication channel have different characteristics. Diversity suggests that there is more than one transmission path or method of transmission available between transmitter and receiver. Diversity, it simply is a method of improving the reliability of a message signal by using two or more communication channel with a different character. This diversity is an important, or diversity plays an important role in fading. That is, we have just mentioned that radio fade. It plays an important role in radio fading and co-channel interference, and avoiding error burst. By using diversity, we can reduce the radio fading, co-channel interference, and avoid error burst. It is based on the fact that individual channel experience different level of fading and interference. Diversity is based on the fact that we use diversity, or we suggest diversity, because it is based on the fact that individual channel, that is, it may consist of one or more channel. Each channel experience different level of fading and interference. The channel which is used in for transmission will be different from experience different level of fading, and it will be different from the other channel which is used. There may be two channel to one or more channel, and for communication, each channel experience a different level of fading and interference. Multiple versions of the same signal may be transmitted and received and combined in the receiver. Here, same signal. Here, diversity suggests one or more transmission path or one or more communication path. So, here, communication channel. Diversity suggests that there will be one or more transmission path or one or more communication channel. Here, through each channel, the same signal may be transmitted and received, and it will be combined in the receiver section. It consists of two channels. Through the two channels, same signal is transmitted. As a result, redundant forward error correction code may be added. It exploits multipath propagation and result in diversity gain, which is often measured in decibels. And when there is more than one transmission path, or method of transmission available, the system can select the path or the method that produce highest quality received signal. In the receiving section, it will check which transmission path have highest quality. Depending upon that, this will select. Diversity in a microwave system, the purpose of diversity is to increase the reliability of the system by increasing its availability, and when there is more than one transmission path or method of transmission, the system can select the path or the method that produce the highest quality received signal. As we have said, in diversity, there is more than one transmission path or method of transmission. That is, there will be more than one communication channel. Through each channel, same signal is transmitted and transmitted and received, and it is combined in the receiver. Then at the receiver, the channel which have highest quality received signal is selected. Generally, the highest quality signal, how it is selected? It is selected by determining the highest quality is determined by evaluating the carrier to noise ratio at the receiver input. Here at the receiver input, we will calculate the carrier to noise ratio. Depending upon the carrier to noise ratio, we will select the highest quality channel which contains the signal. And at the receiver, by measuring the received carrier power. This carrier to noise ratio at the receiver input is simply achieved by measuring the received carrier power. By measuring the received carrier power, we can calculate the carrier to noise ratio. By evaluating the carrier to noise ratio, we can select the channel which consists of highest quality signal. The most commonly used methods to achieve the diversity are frequency diversity, space diversity, polarization diversity, hybrid diversity, quad diversity, and receiver diversity. These are the most commonly used diversities. We will explain in detail. Before that, once again, we'll come through diversity. Microwave system use line of sight transmission. Therefore, a direct signal path exists between transmit and receive antenna. That is, in microwave systems and satellite communication, etc., line of sight propagation exists. In line of sight propagation, the transmitting antenna and receiving antenna should be in view of each other, and if there should not be any obstacles between them. If obstacles occur, if the signal path undergo a severe degradation means some obstacles like mountains, etc., a severe interruption will occur. There should be a straight line of path between transmitting and receiving antenna. That is microwave system use line of sight transmission. As the time increases, as the time goes, radio path loss varies with the atmospheric condition that can vary significantly, causing a corresponding reduction in received signal strength. As of 20 dB, 30 or 40 or more dBs. This means that as the time goes on, the atmospheric condition can vary significantly. As a result, it will result in radio path losses. When radio path losses vary, a corresponding reduction in the received signal strength will be there, and it can be of 20 dB, 30 dB or more dB. The reduction in the signal strength is temporary, as the atmospheric condition can vary for a period of time. As this atmospheric condition is not constant, the reduction in signal strength is temporary, and it is referred to as radio fade. So, in order to avoid this radio fade, co-channel interference, and avoiding error burst, we use diversity. We use the scheme diversity. So, as atmospheric conditions vary, the radio path losses occur, and it may be in the range of 20, 30 or 40 or more dB. As the radio path losses vary, the reduction in signal strength occurs, and this reduction in signal strength is temporary, and it is referred to as radio fade. This radio fade may be for a short period of time or few milliseconds, which is termed as short-term radio fade, or it may occur for several hours or even days, depending upon the atmospheric condition. And this may be and the radio fade which lasts for several hours or for even days, it is termed as long-term radio fade. Then, in order to control the radio fade or reduction in the signal strength, automatic gain controlled circuits are inbuilt in radio receiver, and this automatic gain control is simply a closed loop feedback circuit which maintains the amplitude of signal at the output irrespective of the amplitude in the input signal, and this AGC can compensate for fades of 25 dB depending upon the system design. However, if the fade is excess of 40 dB, if the fade crosses 40 dB, there will be a total loss of received signal. Received signal will be a total loss. Hence, this when this happens, service continuity, there will be a loss of service, or service continuity is lost. When the fade is excess of 40 dB, total signal will be lost, and service continuity is lost, or there will be a service discontinuity. So, in order to avoid this, a technique is used that are used to minimize this problem of radio fade are known as diversity technique, which means adopting more than one method or diverse method. That is, more than one method in the sense that by using more than one channel or one transmission path. So this diversity technique is the technique which is used to minimize the problem of radio fade, and it can also minimize or co-channel interference problem, and it can avoid, by using diversity technique, we can avoid the error burst. So there are different diversity technique which which minimizes the problem of radio fade, and diversity suggests that there is more than one transmission path or method of transmission available between transmitter and receiver. That is, there is more than one communication channel between transmitter and receiver, and it is based on the fact that, and diversity scheme or diversity technique is based on the fact that individual channel or each transmission path experience different level of fading and interference. That is, both this communication channel or transmission path are individual channels, and this level of fading and interference experienced by each channel is different, and multiple version of the same signal, and through the each channel same signal is transmitted. As in the diversity technique, there will be two channels or two transmission path. Through the each channel same multiple version, that is multiple version of the same signal is transmitted and received and combined in the receiver. As a result, redundant forward error correction code may be added. In order to this diversity scheme also exploit the multipath propagation and result in diversity gain, which is often measured in decibels. This diversity suggests multipath propagation. That is, multipath propagation in the sense that it uses more than one transmission path. That is multipath propagation. This diversity technique exploit multipath propagation, and it results in diversity gain, which is when we use multiple antenna transmit delayed version of signal, creating frequency selective fading, which is equalized at the receiver to produce diversity gain. With multipath fading, this diversity gain is more than antenna gain. Here, this diversity technique, it exploits the multipath propagation, and when we use multipath propagation, the diversity gain, which is measured in decibels, is more than the antenna gain. So, by using the diversity technique or diversity scheme, it exploits the multipath propagation. As multipath propagation, while using multipath propagation, it results in diversity gain, and diversity gain is more than antenna gain in this scheme. In a microwave system, the purpose of using diversity is to increase the reliability of the system by increasing its availability. That is, in microwave system, why we use diversity is to increase the reliability of the system. That is, to increase the consistency of the system by increasing its availability. That is, when there is an obstacles, when there is a loss of continuity or service continuity is lost, the reliability of the system won't be there. That the consistency of the system or the consistency of the communication won't be there. So, in order to increase the reliability of the system, by increasing its availability, that is by increasing its availability in the sense that there will be two communication channel for transmitting one signal, that is multiple versions of the signal is transmitted between two transmission paths. So, in case of any interruption in one channel, we can use the other channel. That is by increasing its availability. Increasing the availability means by giving two channel, by making available of two channel, the reliability, that is the consistency of the system, is increased. In a microwave system, the purpose of using diversity is to increase the reliability of the system. That is the consistency of the system. Consistency of the system, how it is increased? It is increased increasing its availability by means that by making use of two communication channel. When there is more of transmission available, when there is more than one transmission path or method of transmission available, the system can select the path or method that produce highest quality received signal. That is, When there is here in diversity, there will be more than one transmission path or transmission channel available. Then the receiver, in the receiver side, the signal or the channel which have highest quality received signal will be selected. How we can measure the highest quality received signal? Generally, the highest quality received signal is determined by evaluating the carrier to noise ratio. CNR ratio is measured at the receiver end. The CNR ratio, the CNR ratio will decide the high quality received signal from the transmission path. Generally, the highest quality is determined by evaluating the CNR ratio at the receiver, and the CNR ratio is simply by measuring the carrier power, received carrier power. By measuring the received carrier power, we can evaluate the carrier to noise ratio. This carrier to noise ratio or CNR ratio decides the highest quality received signal from the two transmission path. And although there are many ways of achieving diversity, the most common method used to achieve the diversity are frequency diversity, space diversity, polarization diversity, hybrid diversity, quad diversity, and receiver diversity. We will discuss each of these in details. First one is frequency diversity. Here, this is the figure shows the frequency diversity microwave system. Here the input, we will explain each block. IF input signal is given to a power splitter. This power splitter, what is meant by power splitter? Power splitter is a divider, which is also known as power dividers, and when used in reverse, when it is used in reverse process, it is power combiner. Here it is a power splitter. This power splitter equally divide the power of input signal, that is input IF input signal power is equally splitted among the multiple output. Here there are two output IF which goes to microwave transmitter frequency A and IF which goes to microwave transmitter frequency B. So the power splitter split the powers of the input signal equally among the two output signal. It reduces the effect of radio signal distortion that occur on one frequency component but does not occur on another frequency component. And the microwave transmitter frequency A and the output from the microwave transmitter frequency B is RF, which is up converted. IF is up converted to RF, and this is given to a filter and combining network, which is a opposite of power splitter, that is combiner, and this is given to a transmit antenna, and there is a receive antenna in the filter and separation network, which again is a opposite process of this filter and combining network. It separates the radio frequency among two output signal, which is given to a microwave receive frequency A and microwave receiver frequency B. The output of the microwave receiver frequency A and B is an IF signal, that is RF is converted to IF, and here there is a quality detector. This quality detector detect which signal have highest carrier to noise, which signal have highest quality among the two channels. There's two channel, one is A channel, next is B channel. So which the quality detector detect which channel have highest quality, and accordingly it will select and it will give to IF switch and out. We'll discuss in detail. This is the basic block diagram of frequency diversity microwave system. Frequency diversity is simply a modulating two different radio frequency carrier with the same IF intelligence, then transmitting both radio frequency signal to given destination. It simply modulates two different RF carrier frequency. Here one IF carrier frequency is given to power splitter. It is splitted. The power is splitted among two output. It is given to a microwave transmitter frequency A. Here, the one IF, that is one IF output signal from power splitter is given to microwave transmitter frequency A, which is converted into RF. That is, the IF is modulated to RF with the same IF intelligence. The IF have this power splitter output have the same intelligence as IF. This IF and this IF have same. The input IF and the output, the power splitter output IF have the same intelligence. With the same intelligence, it is modulated to RF by passing through microwave transmitter frequency A. That is, frequency diversity is simply modulating two different RF carrier frequency with the same IF intelligence, then it transmits both the RF signal to the given destination. That is, one signal, single IF frequency is the input signal, and it is given to a power splitter. The output of the power splitter contains the same power of input signal. It consists of two output with the same power or same intelligence of input signal, and it is modulated to RF with the same intelligence of input, and it is transmitted and this both RF, not only one RF, both RF are given to a filter and combining network and transmitted to this transmitting antenna. Once again, this is the transmitting section. Here the IF input is given to a power splitter. The power splitter, what it does is, this power splitter is also known as power dividers, which is used in reverse as power combiner. It equally divides the power of an input signal among multiple output. This IF have the same power as this, and both this IF have same equal powers, and it is modulated to RF by passing through microwave transmitter frequency A and B. Both this RF are combined in the filter and combining network and transmitted. Now, at the destination, or this is the destination part or the reception part, both carrier are demodulated. That is, here it is combined and transmitted. So this combined signal is separated by passing through filter and separation network. Then the output of the filter and separation network is two RF signal, one which goes to frequency receiver A and another which goes to receiver B. At the destination, both carrier are demodulated. Here RF is demodulated to IF, and here in receiver B, the RF input is demodulated as IF. So at the destination, the combined signal is gets separated by passing through filter and separation network, and the output of this is a RF signal which is demodulated by passing through receiver A as IF, and another RF which comes from the separation network is demodulated by passing through receiver B, and this is given to a quality detector, and the quality detector detect a signal which yield better quality IF, and quality detector, what it does, it yields the better quality IF signal. This figure shows the single channel frequency diversity microwave system. This is a single channel. There is only one channel transmission, but it uses two frequencies. That is, there is a frequency diversity channel, and the IF input is fed to the power splitter, which highest input is fed to a power splitter, which direct it's to a microwave transmitter A and B. The RF output from the two transmitter are combined in the channel, that is combining network, and it is fed to the transmitting antenna. At the receiver end, the channel separator or the channel separator network directs it to receiver A and B, RF carrier to the respective microwave receiver, where they are down converted, that is RF is demodulated to IF. The quality detector circuit here, it determines which channel A or B is the higher quality and direct that channel through IF switch, which is further demodulated to baseband. This, the IF switch between each receiver A and B. The IF quality detector, what it does is, it select the receiver output which have highest quality, and it is given to IF switch. The output of the IF switch is IF out, which is again converted to baseband signal, or which is again demodulated to baseband signal. Many of the temporary adverse conditions that degrade an RF signal frequency are selective. They may degrade one of the frequency or more than other. Therefore, over a period of time, the IF switch, this IF switch may switch back and forth from the receiver to receiver B and vice versa. This IF switch, this IF switch may be switched back and forth from receiver A and receiver B. This switches from receiver A and receiver B back and forth depending upon the time and atmospheric condition. Frequency diversity arrangement provide a simple and complete equipment redundance and have additional advantage of providing two complete transmitter to receiver electrical path. And so this disadvantage is that it doubles the amount of frequency spectrum and equipment necessary. One of the disadvantage of the frequency diversity arrangement is that here it doubles the frequency spectrum. Here we convert it into two frequency spectrum, one which goes through microwave transmitter frequency A, that is one RF, and another which goes through microwave transmitter frequency B, that is another RF. Here there is an amount of, the amount of frequency spectrum is double. This is one of the disadvantage of this, and there is an equipment necessary. There are many equipment used in this system, so there is an equipment necessary. So we will discuss the points. Frequency diversity is simply modulating two different radio wave carrier frequency, the same IF intelligence, then transmitting both RF signals to the given destination. That is IF input given to a power splitter. The power splitter is output is the IF which have same power, and it is it is modulated or up converted by passing through microwave transmitter frequency A and B, and the corresponding outs from the A and B, that is RF, which is given to a filter and combining network, and it is combined and as one signal and transmitted by transmitting antenna, and the receive antenna, the combined signal is get filtered by passing through filter and suppression network. The output of the filter and suppression network is RF, which is given to microwave receiver frequency A and B. The output of the receiver is IF, that means here by passing through receiver A, the RF get demodulated or down converted to IF, which is given to quality detector. The quality detector check which receiver output have highest quality, and accordingly it select the corresponding one with highest quality and given to IF switch. This IF switch back and forth depending upon the atmospheric condition and time. Finally the IF out, which is again demodulated to baseband. That is, at the destination both carrier are demodulated, and the output that yield better quality IF signal is detected, and the IF input signal is fed to a power splitter which direct it to a microwave transmitter and A and B. The RF output from the two transmitters are combined in the channel combining network and fed to transmitting antenna or transmit antenna. At the receive end, The channels separated direct A and B RF carrier to the respective microwave receiver where they are down converted to IF. Here the quality detector circuit B is the higher quality and direct that channel to be further demodulated to baseband. The disadvantage of the method is that it doubles the amount of frequency spectrum and equipment necessary. Now we will discuss about the space diversity, which is another type of commonly used diversity technique. This is the block diagram of space diversity. Here, the space diversity, the signal is transmitted over several different propagation paths. And in the case of wired transmission, it can be achieved by transmitting via multiple wires. And in the case of wireless transmission, it can be achieved by antenna diversity, that is using multiple transmitter antenna, that is transmit diversity, or multiple receiving antenna or reception diversity. Here, in this space diversity, the signal or the information is transmitted over different propagation path. That is, there may be two or one or more communication channel or propagation path between transmitter and receiver. In case of wired type of communication or wired transmission, this is achieved, that is, the space diversity is achieved by transmitting via multiple wires. That is, there may be more than one wires for transmission. In case of wireless transmission, that is by using antenna, by using two antennas, that is that by using multiple transmitter antenna called transmit diversity, or receiving antenna by using multiple receiving antenna called reception diversity. The figure shows in case of wireless transmission, it uses antenna diversity. Here we have transmit diversity and reception diversity. The figure B shows the transmit diversity. Here it uses multiple transmit antenna. So this is examples of, this is a figure for transmit diversity, and the figure A have two receiver antennas. So it's an example for receiver diversity. We'll discuss the space diversity in detail in next class.